Industry 4.0 is the integration of data, artificial intelligence, machinery, and communication to create an efficient industrial ecosystem that is not just automated, but also intelligent. Within Industry 4.0, 9 technological pillars have been defined. These pillars outline the new technology manufacturers are using to improve all areas of production processes. These pillars are expected to have a widespread impact across all industries and society as a whole. 1. Big data and analytics. The aim of this pillar is to analyze huge data set to optimize production and improve services. 2. Augmented reality. Augmented reality displays digital content in the real world through a device, such as a mobile phone or special eyeglasses. 3. Simulation. Will leverage real-time data to mirror the physical world in a virtual model that will include machines, products, and humans. 4. Internet of Things. With the industrial Internet of Things, an ever greater number of products will incorporate intelligence and be connected using standard protocols. 5. Cloud computing. Cloud computing uses a network of remote servers to store, manage, and process data. 6. Cybersecurity. Sophisticated identity and machine access management systems will be used to provide secure, reliable communications. 7. Horizontal and vertical system integration. The entire organization will be interconnected, and companies will be connected with one another. 8. Additive manufacturing. 3D printing innovations are now making a significant impact in design, prototyping, and low-volume production. 9. Autonomous systems. Autonomous technology allows for machinery and robots to act and behave autonomously after being programmed to do so. The main objective of the 4STEPS project is to support the successful RIS-3 implementation, applying the Industry 4.0 and its thematic pillars to all the industrial sectors identified by the 7 Central European regions involved in the project. In a joint collaboration, the 4STEPS Consortium has already achieved numerous outstanding results. In the first half of the project, an Industry 4.0 checkup tool was conducted by 355 Central European SMEs. Based on the SME results, 8 country mapping reports have been prepared by project partners, where the main conclusions have been highlighted. The involved companies were clustered at transnational level in relation to the 9 Industry 4.0 pillars, and 5 clusters were statistically feasible and realistic, followed by profiling of the individual groups. The partners jointly defined the Transnational Maturity Level Index, which consists of 6 different dimensions, in order to evaluate companies' level of innovation. The 4STEPS Consortium has elaborated a 140-page-long Industry 4.0 supporting tool catalog, which is intended to collect the possible services provided by project partners in relation with Industry 4.0. Following the transnational analysis, the 4STEPS partners proposed 35 possible actions, which shall be concrete services to be implemented by the digital innovation hubs. Currently, partners have been organizing regional workshops to upgrade digital skills of different stakeholders. In the last year of the project, 7 pilot actions shall be conducted. Due to the transnational analysis conducted by the SMEs, numerous outstanding results can be highlighted in connection with companies' level of adaptation and their needs to Industry 4.0. Let's see the blue columns, where the proportion of companies are shown who are currently using or offering the specific Industry 4.0 technologies. The green figures are revealing the ratio of SMEs who are planning to use or offer the Industry 4.0 technologies in the near future. In the third last year of the 4STEPS project partners conducted their pilot actions to offer new Industry 4.0 related services to stakeholders. The 2 Italian partners organized a lab targeted to business innovation development and supported the development of new products and services linked to the Digital Innovation Hub. In Poland, Digital Innovation Hub was developed on the base of Fab Lab. 3D modeling, reverse engineering, production line programming, and robotics are the focus areas. The Austrian partner implemented a cyber-physical system which integrates the resources of customer and considers their particular needs and requirements to set up of and to simulate an automated smart service factory. The educational concept in the Czech Republic aims to develop skills and improve competencies of managers of SMEs in order to better cope with challenges related to Industry 4.0 transformation. In Slovenia, a regional stakeholder group was defined, who created the tools and services that are being offered by the DIH. In Germany, innovation events were realized on augmented reality, virtual reality, and 3D simulation topics, with addressing specialists from certain application fields and industrial sectors. In Hungary, advanced data analysis was conducted using huge dataset of companies to measure how they reacted to crisis.